started. All right, transaction log. So you have seen transaction logs when we created the database, right? When we created the database, we have seen that you can create a database with more than one transaction log. And but at that time I mentioned that you are not going to see a database with more than one transaction log, because even if you create a database with more than one transaction log, the second transaction log onwards is going to be used only if the first transaction log is full. And if a DBA is doing the proper work, the first transaction log never going to be filled, so that the chances of using the second transaction log is absolutely zero. So that's the reason why you never ever going to see a database with multiple transaction log. It's always going to be one transaction log. And what is the extension of the transaction log? The transaction log extension is .ldf, right? Okay, so let me open a file here. Just a second, guys. So let's talk about the transaction log. So transaction log is nothing but a file which can be stored in one of the folder in the storage system. Now, when you create the transaction log, you can specify what is the initial size, what is going to be the incremental size. If you want to provide a maximum size, you can do all those things during the creation part. Now, when the transaction log is created, now what information is going to be returned into the transaction log? Anyone? What information is going to be returned into the transaction log?
Any update, insert, or delete?
Any update or it is not going to be any insert, update, or delete. It is going to write information about insert, update, and delete.
Information change.
Yes, into that transaction log. Now, normally when you are updating a record, please mute the microphone. When you are updating a record, well, the update is actually happening at the memory level, right? We talked about how SQL Engine load 8 kilobyte pages from the hard disk to the memory, and then in memory 8 kilobyte page get updated. Then the moment that page is updated, we call it as dirty page. Later the SQL Engine will flush these dirty pages back into the hard disk, which is called as checkpoint. We talk about all these things in one of the previous classes. Now, so data changes actually happens in the memory level, but information written into the transaction log, it is physically being written into LDF file in the hard disk. So information, the SQL Engine will directly write information into the transaction log. There is no memory involved in it. It's going to be physical write. Okay. Now, talking about the transaction log internal structure. Let me see. LChap, let me see what's going on. Are you okay? I mean, can you hear me? I see you put some comments there. Sukhdev, you have been unmuted, okay? All right. Okay, LChap, I see you are here. You are unmuted now. Can mute the microphone. Okay, so now when you create, LChap, please mute the microphone. Okay, so the transaction log, when you create a transaction log, the transaction log is going to be split into multiple virtual logs. So this is what that virtual log is. So you can assume that this is one transaction log file. That transaction log file is divided into multiple virtual logs. Now, the total number of virtual logs, how SQL Engine is going to divide that, it's all taken care by the SQL Engine. You don't have a say on it, but you need to understand that one single transaction log will be divided into multiple virtual logs. Now, the way SQL Engine is writing information into the transaction log is slightly different. Normally, when you start writing something, you start from the left-hand side to the right-hand side. But when SQL Engine write information to the transaction log, it is always going to start from the middle of the transaction log. So it is going to start writing information in the transaction log like this. Once it reaches the end of that file, it is going to wrap around and then continue its writing from the other side. And so that is going to continue until it reaches the middle of the transaction log. Now, let's say I created a database, a lot of transaction happens. So it is going to start writing information from the middle of the transaction log and then wrap around and continue from the other side. And once the transaction log is full, what would be the next step? Once the transaction log is full with data, let's say I created this transaction log with a 1 GB size, and the entire 1 GB is already been entire 1 GB information is written into the transaction log, then we call it the transaction log is full, right? So what would happen when the transaction log is full? Once the transaction log is full, do you think the database is going to crash? Or there is no more database is still going to be up and running, but no more transactions possible on that database? What do you think?
No more transaction, maybe.
Yes, no more transactions possible. When you try to perform a transaction, it is going to generate an error. So database is up and running. You can still perform read operations, but no insert, update, delete, or any statements which involves a transaction is not possible in the database. Now, when the transaction log is full, the first thing SQL Engine is going to check is whether the transaction log is enabled for an auto growth. If the transaction log is enabled for an auto growth, let's say 10% auto growth, then initial size is going to be 1 GB, 10% of that is going to be 100 megabytes. So SQL Engine is going to increase that transaction log size to another 100 megabytes. So how SQL Engine is going to do that? It is going to stretch the transaction log to both direction. And by doing so, it is going to create additional 10 MB, 100 MB space right in the middle. So SQL Engine can continue writing in that 100 MB additional space. Okay, so stretching the transaction log and then creating additional space right in the transaction log, in the middle of the transaction log, is a time-consuming process and a resource-intensive operation. And well, also the irony is that this the transaction log file growth actually happens right in the middle of the transaction. So your transaction is going to be in a suspended state until that file growth is actually completed. So anything which actually going to delay the transaction, as we said, it is a bad thing to happen. So what we normally do, that's the reason why I always recommend you need to create a good amount of initial size and a fair amount of auto growth size. You don't want to increment the transaction log by 10 MB, 20 MB, 30 MB. That is going to be too small. That will result to frequent auto growth happens for the transaction log. So when you're working on transaction log, make sure that you give a good initial transaction log size, and the incremental size of the transaction should also be a good amount. So in that way, the auto growth, the frequency of auto growth can be kept to in an acceptable limit. All right. Okay. Now, in any kind of logging, I mean, let's say you let's talk about a real-time scenario, your vehicle mileage log. Let's say you have a business and then you purchased a vehicle for your business, and then as per the IRS rule, you need to keep a mileage log, right? And then the mileage log, you need to keep track of all the travel you are making for your business, and then for each entry in that mileage log, there is going to be a sequence number. Let's take attendance. Let's take attendance log. I mean, for each entry in the attendance log, there is going to be a corresponding sequence number. Similarly, transaction log, each entry in the transaction log is having a corresponding unique sequence number, and that sequence number is what we called as log sequence number. So log sequence number is the unique sequence number for each entry in the transaction log. That is what the log sequence number is. We normally call it as LSN, a log sequence number, or LSN. Is it clear what is an LSN is? Log sequence number. Any questions on any of the terminologies we discussed so far? Going to be a lot of theory, okay? To listen to this carefully. All right. Now, when information about a particular transaction is being inserted into the transaction log, how long that information is going to be kept in the transaction log? Let's say I'm performing a transaction and the transaction consists of 3 update statements. Information about those transaction and the update statement will be returned into the transaction log. And finally, the transaction is committed. Now, the question is, once the transaction is committed, how long the SQL engine is going to keep those entries in the transaction log? Anyone?
I think that is not permanent.
It is not going to be permanent now. Then your transaction log is going to grow exponentially.
24 hours?
Not 24 hours. Well,
based on initial settings.
Based on?
Initial settings?
Not based on initial setting. Well, to answer that question, well, let's take a look at what is the need of these entries in the transaction log. We keep on saying that information about a transaction will be written into the transaction log. Keep on saying that. But what is the need of writing information about a transaction into the transaction log? Let's think about that first. What's the advantage you get from writing information about a transaction to the transaction log? In case there is
For data recovery.
For data recovery. There are 2 reasons why we write information to the transaction log. One for a rollback, and another reason is data recovery or database recovery. Now, when you, let's say I started a transaction, I have, let's say, 100 different insert, update, and delete statements. And after 60 statements, my programming logic is in such a way that I'm going to check some conditions, and that condition is false. Then I want to roll back the entire transaction. So how SQL engine is going to roll back transactions right in the middle of a transaction? How SQL engine know what are the changes happens in that transaction, right? When you're trying to roll back a transaction right in the middle of a transaction, how SQL engine know that what are the data changes happen in that transaction so that it can roll back? Well, if you perform a rollback statement, SQL engine will come back to transaction log and verify, hey, what are the data changes happen in that transaction, because transaction log has an entry on each and every changes happening in that transaction. So SQL engine will refer back to the transaction log to identify what are the data changes happen in a transaction, and then based on that, the rollback is going to happen. So the entries in the transaction log is going to support rollback statements in a transaction. Okay. Now, the same scenario, if you are trying to roll back to a particular save point, same thing, that the SQL engine still going to use information stored in the transaction log to roll back to a particular save point. So that is a first use. So I said that there are 2 reasons why we want these entries in the transaction log. One is for the rollback. Now, the second reason is for database undo redo operation. Anyone remember what is a database undo redo? We discussed that before. Or in general, we call it as database recovery. So let's say when a database get rebooted, and when the SQL engine comes back online, well, SQL engine will scan through the transaction log looking for all committed transactions, but the corresponding data changes are not there in the hard disk. So what the SQL engine will do? SQL engine will replay those entries in the transaction log to recreate those entries in the data file. Can you tell me in what scenario you can see data changes happen in a committed transaction not there in the data file? In what scenario you would not see the data changes happen in a committed transaction is not there in the data file? We discussed that before.
If the power failure or something is happened before the SQL Server write back before writing back to the hard disk,
right,
from the memory.
Right. Very good. So when the data change happens, let's say I'm performing an update statement. This is just a recap. Okay, we discussed this before. When a data change happens, information will be written into the 8 kilobyte page in memory, and then it become a dirty page. But before dirty page get a chance to return back to the hard disk, if the SQL Server get restarted due to any reason, those data changes happened in the in the data in the memory is going to be gone. So you only time you will see data changes corresponding to a committed transaction is not there in the hard disk, means SQL engine did not get a chance to write those changes back into the hard disk. So SQL engine will use the transaction log entries and try to recreate that data changes, and that process is what we called as recreating the data changes with the help of entries in the transaction log is what we called as, oh come on guys, you forgot all those. Redo, right? Redo operation, right? So now you need now understand that the another reason why we want to write information in the transaction log and keep it even after the transaction log is committed. The transaction is committed. It's always a question why you want to keep committed transaction entries in the transaction log. The answer is in case you want to perform a redo operation, right? So now you tell me how long you want to keep, or how long SQL engine will keep transaction log entries in the transaction log. Is it going to be only until the transaction is committed, or is it going to store even after the transaction is committed?
Is the recovery interval?
No, until they are written into the MDF file.
Yes, until it is been returned into the MDF file, right? So until a checkpoint happens. Checkpoint is the command you need to use to write dirty pages back into the hard disk. So let's say I started a transaction is committed, information about that data changes physically returned into the hard disk of the data log file, and then the moment the checkpoint is issued after my transaction, that means whatever data changes happened as part of my transaction is physically returned into the hard disk. Moment all the data changes in my transaction physically returned into the data file, I don't need those transaction log entries anymore, right? So the answer for that question, how long these entries is going to be there in the transaction log? Well, you need to keep that, then the SQL engine will keep those transaction log entries until SQL engine perform a checkpoint command. So SQL engine, when you look at the transaction log, there are two type of entries in the transaction log. One is called as active entries, another one is called as passive entries. So the entries in the transaction log is going to be divided into two: active entries and passive entries. Active entries are those entries in the transaction log which is still needed for a redo operation. That is what we called as active entries. Active entries contains entries for a committed transaction. Active entries contains entries for a uncommitted transaction. But the common scenario is that all the entries needed for a redo operation is still going to be there in the active area of the transaction log. Now, how about the passive area or the passive entries? Passive entries are entries in the transaction log whose entries in the transaction log which is not needed anymore. When I say a transaction log entry is not needed anymore, that means the corresponding data changes is already been physically written into the data file. So those entries in the transaction log which is not needed anymore for an undo operation or a rollback statement is what we called as passive entries. So the transaction log always contains active entries and passive entries. Is it clear what is an active entry and what is a passive entry?
Can you please
Yeah,
repeat once passive entry?
Yes, the active entries are those entries in the transaction log which is still needed to perform a redo operation. Okay, right? Redo operation means if I have an entry in the transaction log and the corresponding data changes for that entry is not physically written into the hard disk, then those entries are what we call as active entries. Those active entries are those entries we still need to perform a redo operation. Now, how about the passive entries? Passive entries are entries in the transaction log which is not needed anymore for a redo operation. Is that clear now?
Hello, Daniel.
Yes?
Yeah, so is that you are saying passive entries are physically there in transaction log, even though we don't need them?
Yes. Both passive and active are physically there in the transaction log. Yes. Now,
Okay,
gradually, SQL Engine will eliminate passive entries. We'll be seeing how SQL Engine is going to do it. But at any point, there is going to be active entries and passive entries in transaction log.
okay, thank you.
Any other questions?
Yeah, but why does it keep the passive entries? Because previously we said when a check might happen, it's gone.
Yes. No, it's not going to go on immediately after the checkpoint. There's a reason. I'm going to tell you why it is not going to immediately be removed from the transaction log. But gradually, SQL Engine will do that. I'm going to discuss that right now. El Chapo, you have been unmuted. All right. Okay. The reason why SQL Engine now, the process of removing passive entries from the transaction log is what we call as truncate. We constantly use the terminology truncating the transaction log. Truncating the transaction log means removing passive entries from the transaction log. Okay. So the truncate happens in the unit of truncate is going to be a virtual log. Let's think about this. This particular virtual log, take virtual log number 2. Okay, right now the virtual log 2 contains, let's say, 50% active entries and 50% passive entries. But if SQL Engine know that these passive entries need to be removed, but the SQL Engine cannot truncate a portion of the virtual log, it can only truncate a complete virtual log. So what SQL Engine need to do? SQL Engine need to wait for this entire virtual log filled with passive entries, so then SQL Engine can perform a truncate operation at the virtual log level. So that's the reason why SQL Engine will not immediately get rid of all the passive entries. It will wait for that virtual log to be completely filled with passive entries. Then only it can perform a truncate. Is that clear now, Jitendra?
Yeah, that's clear.
Yes. So that's the reason why it's not going to immediately get rid of that.
But isn't it the issue like when this truncate is happening and maybe the next virtual log, half of that is also passive and this is full passive. The virtual log 2 is like passive now, right now.
Let's say the virtual log 1 is completely passive and the virtual log 2 is half passive and half active, then it's only going to truncate the virtual log 1. It cannot truncate the virtual log 2 at that time because it still contains active entries.
Okay, and yeah, that's fine. And even if the one of the transaction is both in the virtual log 1 and virtual log 2, I mean, one of the checkpoint that happened was between the virtual log 1, and now the next checkpoint is like right in the middle of the virtual log 2, and which is like half active and a half passive. That matter, or is just?
Yeah, I mean, it's a very simple. Let's say I started a transaction here, and the transaction ended here, and now this particular transaction is informed. Whatever data changes happen in that transaction is not been returned to the transaction log, so you cannot truncate the virtual log 1 and virtual log 2 either. You need to wait for an entire virtual log to be filled with 100% passive entries, then only it can truncate that virtual log.
Yeah, so it's not going to truncate if half is there, half is into
it's not, it cannot do that.
So the virtual log 1 also need to wait for the virtual log 2 to get passive if a transaction is overlapping into both.
That's right. That's right.
And Daniel, how are these virtual logs are divided in the transaction logs? So like on what basis they are like divided?
It is going to be, there's my SQL Engine use some kind of an algorithm for that, but we don't have any say on it. What's going to be the number of virtual logs and what is the size of it, because this virtual log size here, you can see that we evenly divided it, right? But it can be some of the virtual log is having higher size comparing to the other ones. So it's all taken care by the SQL Engine. We don't have a say on it.
Oh, and Daniel, for example, let's say the virtual log has like a 3/4 passive and then 1/4 active, and then we come to the virtual log 2, which is like still like active records, and then let's say virtual log is completely filled with passive and they're truncated completely. So does the records in the virtual log like move to virtual log 1 to create a space?
It is going to be the virtual log 2 is going to be completely filled with empty space. Now that space is not going to be released back to the operating system. It is going to stay there, and then it can be reused. That space
But
can be reused. It is not going
but
to
the
move to the virtual log, the next virtual log. It is going to stay as virtual log itself, and then SQL Engine will reuse it at later point.
so in between the virtual log is like cleared because it's truncated. So it means the virtual log they still have the records, but virtual log 1 will have the empty one, right? And it will be
Yes.
reused, right?
Yes, it is going to be reused.
So it's not like going to move from one virtual log
No,
to
it
other
is not
virtual
going
log.
to. It is not going to move the space now.
Thanks, Jim.
Daniel, just like question related to the previous one. Based on that, like transaction going to the next virtual log, which is going to be half active or half passive, or is it based on the checkpoint? Like one checkpoint happened in the middle of the virtual log 1, or is it always the checkpoint is going to happen at the end of the virtual log?
No, it is going to be checkpoint. That's what we are going to discuss next. When the checkpoint is going to happen and what kind of effect that is going to have this concept called as min log sequence number. So you can repeat that question if you don't get the answer from the next 5 minutes. Okay.
Okay.
Okay. So we talked about log sequence number, right? Now, there is a concept called as min log sequence number. This is always a certification question. What is a log sequence number, and what is a minimum log sequence number or min log sequence number? So there are so many different ways you can explain min log sequence number. The best way you can explain is minimum log sequence number is the lowest log sequence number in the active section of the transaction log. Minimum log sequence number is the lowest log sequence number in the active area or active section of the transaction log. So that is what the minimum log sequence number. And then you can also make a statement that the minimum log sequence number is constantly moving. Why the minimum log sequence? Right now in this case, this is a minimum log sequence number, right? This minimum log sequence number is not going to be a permanent one. Why? Or I can say that the minimum log sequence number will keep on moving.
Because it might the oldest minimum log sequence number would be like passive. It become passive, right?
Yes. So every time when a checkpoint happens, the current minimum log sequence number become the passive entry. So SQL Engine, there is going to be a new minimum log sequence number is created every time when the SQL Engine issue a checkpoint. Okay. So this minimum log sequence number is going to be now the checkpoint can be happen right in the, that's another question, whether the checkpoint can happen right in the middle of a transaction. Answer is yes. Checkpoint can happen in the middle of the transaction. So whatever data changes happen for that particular transaction up to that point will be physically written into the hard disk. Okay,
on what basis this checkpoint will happen, Daniel?
Well, the checkpoint will be happen based on so many different factors. We'll be seeing that very shortly. SQL Engine will automatically issue the checkpoint based on recovery interval, and there are a couple or SQL Engine will, every time when the SQL Engine is not having enough load, SQL Engine will periodically issue the checkpoint command. And for certain actions, for example, when you're creating a backup, well, SQL Engine will automatically issue a checkpoint. So there are 7 different scenarios where SQL Engine can issue its own checkpoint, or you can use the checkpoint command to issue your own checkpoint too. We'll be seeing all those things in tonight class itself, how frequent the checkpoints are issued.
Okay, thank you.
Daniel, but the processing is still ongoing and not all data is written back. Why the checkpoint will happen here? I mean,
because
was the intention just to, even it is also still is running, didn't finish anything.
Yeah, that's fine. I mean, the data changes are constantly happening in your database, whether it is the lengthy transaction or shorter transaction. Only thing the checkpoint is going to do is just write those information back into the hard disk, right? So if let's say you are right in the middle of a transaction, there's a checkpoint happens, well, that data pages, I mean, that information is going to be, or the dirty pages created as part of the transaction so far is going to be returned to the hard disk. And then later, if you perform a rollback, let's say at the end you decide that, okay, I'm going to roll back the transaction. When the SQL Engine roll back the transaction, SQL Engine will modify that 8 kilobyte page again with the previous value, and then it is going to return back to the hard disk with the previous value. So it is a continuous process. Checkpoint has nothing to do with the transaction. It's keep on every time when the SQL engine is not overloaded, or when SQL engine meets reach certain criteria, the checkpoint is periodically issued, irrespective of whether the current transaction has been, or current transaction or transactions has been committed or not.
Okay, so you are saying it is independent.
It is independent.
Okay, thank you.
Okay. All right.
Hi, Daniel.
Uh-huh.
Can you just repeat the definition for min-log number system?
Yes, the min-log sequence number is the lowest sequence number in the active section of the transaction log. We have active and passive entries, or active section and passive section in the transaction log, right? So minimum log sequence number is the lowest sequence number in the active area of the transaction log.
Okay, thank you.
Okay. Now,
sorry, Daniel. Can you just explain again active and passive section? Sorry.
Active section, active entries in the transaction log are those entries which has not been, those entries in the transaction log which has not been, okay, let me rephrase that. The active entries in the transaction logs are those entries of transaction log which is not been physically written into the hard disk, or those entries are needed to perform a database recovery. Those entries in the transaction log are what we called as active entries in the transaction log. Passive entries are those entries in the transaction logs whose data changes are already physically written into the hard disk, so we don't need that transaction log entries anymore. So those entries in the transaction log which is not needed anymore for a database recovery or a database redo operation is what we called as passive entries. Passive entries are entries we don't need anymore.
Thank you.
All right. All right. So we talked about the minimum log sequence number as well. Let me get my pen back. All right. So that is so let's do some. Let's go through these bullet points. Okay, the transaction log is used to guarantee the data integrity of the database and data recovery. We talked about that. A SQL data file is going to log is divided into multiple virtual logs. The virtual log file size are not fixed size, and the database engine chooses the size of the virtual logs. Database engine tries to maintain a small number of virtual logs. When the database is created, the logical file begins at the start of the physical log file. New log added at the end of the transaction log. We talked about that. Log truncation frees a virtual log who's okay. So we discussed that. Min leak in second row, right? The physical file. Okay. All right. So I believe we pretty much covered all the bullet points here. Now, when we talk about the maintenance of the transaction log, well, maintenance of the transaction log consists of two parts. One, truncating the transaction log. Second one is called as stringing the transaction log. Truncation of the transaction log and stringing the transaction log. To understand the truncation of the transaction log and stringing the transaction log, you also need to understand how frequent the SQL engine is going to issue the checkpoint, and there is one more property called as database recovery model. So let's talk about those two before we start working on how to maintain the transaction log. All right, so let me open it. All right.
Then on a small question, like the checkpoint and the LSN are different thing, right?
Yes.
I mean, check is happening separately, and it's not that when a checkpoint happen, the LSN is issued. Right?
No. LSN is going to be for each entry in the transaction log. The LSN is going to be there. For each entry, there is going to be a sequence number, and that is what we called as log sequence number. It has nothing to do with the checkpoint.
Is it each entry or each transaction we're talking
Each
about?
entry, one transaction can contain multiple entries. Don't think that there's going to be one entry for each. No, one transaction can have multiple entries in the transaction log, and each entry in the transaction log has its own unique number, which is what we called as log sequence number.
So that is not based on the virtual logs, right?
No,
Or is
it is not going to be based on the virtual log size now.
oh, yeah.
It is nothing but like a sequence entry. I mean, any kind of a log you come across in your real world environment, I mean, there's going to be a sequence number associated with that.
Okay, I got it.
All right, checkpoint. Now you can, there are a couple, what are the different ways you can issue a checkpoint? You can manually issue a checkpoint. You can say checkpoint followed by a integer number. Integer number is going to be in seconds. So when I say checkpoint 120, you are telling the SQL engine, hey, I'm going to give you 120 seconds. So you better write all your dirty pages back into the hard disk within that allocated time. So never ever give SQL engine a very short time, because if I give a, let's say 60-second or 1 minute, what SQL engine will do, SQL engine will stop all the transactions or all other activities it is doing, and then will allocate all the system resources to write the dirty pages back into the HUD. So if you go for a very short time period here, then you will see that all of the transaction is, the SQL engine is going to slow down, because it's going to spend all the resources for writing the dirty pages back into hard disk. I mean, 120 second is a fair amount of size, the duration. So checkpoint 120, that's going to take 2 minutes to write all the dirty pages back into the hard disk. So this is how you can issue your own checkpoint command. Now let's talk about how frequent SQL engine will automatically issue the checkpoint. Now, the way the SQL engine will decide how frequent the checkpoint need to be automatically issued is based on a property setting here. If you right click on the instance, go to the properties. Now click on the database setting. There is a recovery interval in terms of minutes. So this recovery interval is, you're not saying, for example, if I say recovery interval equals 1, don't think that every 1 minute there is a checkpoint is going to be issued. Now when I say recovery interval 1 minute, I am telling the SQL engine I am going to give you maximum of 1 minute for that undo redo operation, or we call it as database recovery, right? I hope most of you remember what a database recovery is. Database recovery consists of two processes. Which are they? Database recovery consists of two processes. Which are they? Okay, come on guys, don't make me cry. Undo operation and redo operation, right? Undo operation means SQL engine will scan when the SQL engine comes back online after a reboot or after a restore. SQL engine will scan through the transaction log looking for all the transactions which are already been committed, but the corresponding data changes are not there in the data file. So what the SQL engine will do? SQL engine will replay those transactions with the help of those entries in the transaction log and recreate those data pages. The data changes happen in the data file. So that's what we called as redo. Now there's another process called as undo. Undo means it is going to scan through the transaction log looking for any uncommitted transaction, and then all the data changes happen as part of the uncommitted transaction is going to be rolling back. That's called as undo. This database undo and redo combined together, we call it as database recovery. We discussed this in the previous class. All right. So the recovery interval, you are telling the SQL engine, I'm going to give you 1 minute to perform that undo redo operation or database recovery. Now, if you give a time limit on what's the maximum allowed time for that undo redo operation, SQL engine will always keep an eye on the number of dirty pages in the memory, and SQL engine think that, okay, the number of dirty pages available right now in memory, those dirty pages cannot be recovered in that within that 1 minute interval specified. SQL engine will immediately issue a checkpoint. Okay, so the recovery interval you are giving here is actually you're providing a time limit for the maximum time for the undo redo operation. Based on that, the SQL engine is going to periodically issue a checkpoint. Okay, so that is how SQL engine issue the default checkpoints. Normally we will give the value of 0, But if you want, you can. If you want to minimize the time taken for the database to perform an undo redo operation, come online, that's when you put a limit on here. Normally we will give a value of 0, so there is no limit.
You mean why you prefer you said normally we give 0. Why? I mean because you thought just the
we will leave it
data recovery will not happen, or
we will leave it up to the SQL engine to decide when to issue the checkpoint. We are not going to forcefully tell the SQL engine. Okay.
Okay. That means SQL engine by itself it will do.
Yes, SQL engine will automatically, and if whenever the SQL engine is free, SQL engine will issue the checkpoint. Okay. Honestly speaking, this checkpoint interval is going to be like normally it's going to be a couple of milliseconds. It's going to be, if the server is not extremely busy, SQL engine will tend to issue checkpoints every milliseconds.
Okay, thank you.
Now there are other scenarios checkpoints can automatically can happen. I don't remember all the scenarios offhand. Checkpoint, sorry. All right, so we talk about automatic checkpoint based on the recovery interval, all right? And then there is a manual checkpoint, which is using our checkpoint command. We have seen that. Now there is going to be internal checkpoints issued by various server operations, and that's what we are going to see, which are those server operations. Internal checkpoints. Let's copy this and paste it here.
Daniel?
Yes.
So I have a question. So here you're saying checkpoint 120, right? So which is like it's 2 minutes. So you're giving in a time interval 2 minutes, right here?
Yes.
For every 2 minutes, it has to go for a checkpoint.
No. I'm giving SQL engine 2 minutes to write those dirty pages back into the hard disk.
And if for writing back to the hard disk for those dirty pages, if it's going to take more than 2 minutes of time interval, so what's it going to do?
Well, I mean, 120 is the time you are giving, but the SQL engine could not able. There are so many dirty pages. SQL engine will try its best to complete everything in 120 minutes. If it goes beyond 120 minutes, SQL engine will continue. This is a recommendation you are making. Hey, write everything in within that 120 minutes, 120 seconds.
It's the same. Yeah, it's the same case what you have showed in the point and click method. The option of interval. It's the same. Yes. This one is the same. But it's
no. That is different. That is you are telling the SQL engine, I'm going to give you 2 minutes or 1 minute for the undo redo operation. Based on that time frame, SQL engine will decide that, okay, how frequent the checkpoint is going to be issued. That is an indirect way. You are not going to say that when you say recovery interval 1, you are not saying that, okay, I'm going to give 1 minute for checkpoint. I'm saying that 1 minute for the undo redo operation. So SQL engine will monitor the number of 8 kilo dirty pages in memory, and SQL engine think that, okay, let's say we have 108 dirty pages in memory, and SQL engine think that those 100 pages cannot be returned back into the hard disk within that stipulated 1 minute. Then SQL engine will immediately issue a checkpoint command.
Okay, so there it's indirect. First it goes for like undo or redo, then it will go for a checkpoint. Here it's like a checkpoint directly.
That's right.
Thanks, Tim.
Okay.
Is this one issuing a checkpoint right away, or is this one issuing a checkpoint after 120 seconds?
No, it is going to be issue the checkpoint right away. If I execute this, it is going to issue the checkpoint straight away.
Okay, it's like I'm issuing a checkpoint. You better start writing.
You can see that it start executing that query now.
Hello, Daniel.
Yes.
Yeah, the one which you said before, actually it will occur, you said it in millisecond. Which one it is? So if it is not a checkpoint or it is recovery interval?
It's going to, I mentioned that it is going to internally issue the checkpoint there, in a couple of milliseconds. That is a checkpoint, not the recovery interval. It is the checkpoint.
Okay. Thank you.
All right. So you can issue the recovery interval. We already seen that. Then internal checkpoints are, okay, this is going to be, hold on. 1 second. So internal checkpoints. So internal checkpoints, one is going to be recovery interval. Second one is going to be every time when a data file is been added or removed by using alter database statement. So if you are trying to add a new data file or removing a data file, then checkpoint is going to be issued. Very rarely you add or remove data files, but you need to remember that. Now, every time when a database backup is taken, it is going to issue a checkpoint. Every time when you create a database snapshot, a checkpoint. We'll be talking about snapshot later. It is going to issue a checkpoint. Now, if every time, so that's another thing. Let's say you decided to shut down your database. Okay, so you decide that, okay, let's say you install a Windows patch, and at the end, SQL Engine asks you to reboot your machine. So you click on reboot, or you due to some reason you decide that you're going to shut down your machine. So when you're shutting down the SQL machine, yes.
Yeah, the difference between a redo and undo operation, that means recovery, and a database backup. What's the difference between them?
Database backup, we haven't discussed that yet. That's a completely different topic.
But it's different. I mean, is that the synonym with redo and undo operation?
No. Undo redo is you are trying to recover your lost data pages because of a restart. It has nothing to do with the backup. Backup is a completely different.
Okay. Sorry. Thank you.
So okay, let's think about this. So when you are trying to reboot or trying to shut down your SQL Server, sometimes you will see that SQL Engine the operating system is going to take too much time to shut it down. What happened behind the scene is when you are shutting down the Windows operating system, the operating system know that there is a Windows service running on top of that. So it is going to send a message to the operating Windows SQL Server saying that, hey, I'm going to go down, but I'm going to give you time to write all those dirty pages back into hard disk. All right. So SQL Engine depends on the size of the dirty page. Might take maybe 1 minute. It may take 10 minutes to write all those dirty pages back into the hard disk. And once all those dirty pages return back into the hard disk, the SQL Engine will send a message back to the operating system saying that, hey, I am done. You can do whatever you want. So that is the reason why when you're shutting down or restarting a SQL Server, it might take some time. Don't go and don't get frustrated and pull the power cord, because by letting SQL Engine complete this checkpoint, the advantage you are going to get is when the SQL Server comes back online, you need not have to spend too much time on the undo redo operation. So if you're trying to reboot or shut down your SQL Server, and if it is taking a little bit more time, let it run, complete that task. Okay. All right. So an activity require a database shutdown is performed, well, then the checkpoint is going to be issued. Now, so sixth one is an instance of SQL Server is stopped. Like if you try to either you shut down the SQL Server, I mean, there are a couple of ways you can do that. You can go to the services, you can right click on the service and then shut it down. So that's also when the checkpoint is going to be issued. Now, the seventh one is if you are doing a failover, the SQL Server cluster failover happens, then the SQL Engine is going to perform a internal checkpoint. So there are two types of checkpoints. One is the external checkpoint, which is using the checkpoint command, and then you can have the internal checkpoint as well. I hope this answered one of the questions.
The internal checkpoint, is it the one you do yourself, or is it the one the SQL Server does?
Internally it's actually taken care by, it's automatically issued by the SQL Engine itself.
Then the external one is the one you use
yes,
query to write.
That's right. All right. So That is the frequency of checkpoint. Now, I want to cover one more topic before we go back and then talk about how to maintain the transaction log. So that topic is called as, if you right click on the database, go to properties, go to options. There is an option called as recovery model. So for recovery model, you see three options here: full, bulk logged, and simple recovery model. So whatever recovery model you pick, based on that, it is SQL Engine will decide how much information SQL Engine will write into the transaction log for each transaction. Now, so far we were talking about, okay, whenever a transaction happens, all information about the transaction log will be, all information about that transaction will be returned into the transaction log, right? That's what we were keep on saying. But now we are trying to deviate from there. So still it is going to write information to the transaction. Any transaction happens on a database, information will be returned into the transaction log. But the amount of information returned into the transaction log depends on what is the recovery model. Okay. Now, on a production environment, it is absolutely necessary that you need to go for a full recovery model. You're never ever going to see a production database with a bulk logged or simple recovery model, especially with a simple recovery model, too dangerous. All right, so when you're going for a full recovery model, all information about a transaction is going to be returned into the transaction log, no exception. So can anyone tell me what is the advantage of writing all information about a transaction into the transaction log, each and every information? What's the advantage of doing that? If you are trying to log all your activities, what's the advantage you are going to get from that? You can always go back and say, okay, on this particular date, on this particular time, what you are doing, right? So you can backtrack 100% through, right? Because you are writing all your information, all your activities in a logbook. Same concept here. If the SQL engine is writing all information about a transaction in the transaction log, and at any point the SQL engine want to perform a rollback or a database recovery, all committed transaction information can be recovered. There is no possibility of data loss because you could able to recover all data either in a scenario of rollback statement or in an undo redo scenario. Okay, so that's the reason why I said on a production environment, you always want to go for recovery model full, because you want to recover complete data. You cannot afford a data loss on a production environment, right? Now, what is the drawback of going for a recovery model full, or what is the drawback of writing too much information into the transaction log? Anyone?
Time.
Well, normally transactions are sleek and slim, right? It is going to take milliseconds or maybe 1 minute. We are not going to expect transactions span more than 1 hour, 2 hours. I mean, that is a bad design then. Our transactions always has to be sleek and slim. Okay. Now, the disadvantage of a full recovery model is that if you are trying to perform, let's say I'm trying to load 1 million records into a table. Okay. So for each record get inserted, there is going to be an entry written into the transaction log. So that means 1 million records means minimum 1 million information, 1 million lines of 1 million lines will be written into the transaction log. And now you can see that those 1 million lines is going to be physically written into the hard disk, right? There's no memory involved in this. All the entries returned to the transaction log is going to be physical writes. So you can see how much load it is going to create on that disk, and it is definitely going to slow down your transaction. So writing too much information into the transaction log for large insert, update, and delete is going to slow down the transaction. Okay, but the benefit you are going to get is, in case there is a undo redo need to be performed after that transaction is committed, SQL engine will do that and recover that entire 1 million records with the help of the transaction log. But if you have a scenario where you want to insert or update or delete large volume of record into a table or tables without much performance issues, what you can do is that you can change the recovery model temporarily from full to bulk logged. So when you change the recovery model from full to bulk log, amount only 20% information will be written into the transaction log comparing to the full recovery model.
So Daniel, why would you want to change it to that so you can get 20%?
Because I have a very lengthy transaction, and I do care more about the performance of that transaction than recovering all the data changes happens in that transaction. If I'm trying, that's the same example I'm talking about. If I want to insert 1 million records into the table and I only care about inserting those 1 million records as quick as possible, I don't care much about whether I could able to recover those 1 million records in case if I need it later. So if I don't care about data recovery, I only care about the fastest insert, update, or delete, then I can temporarily change the recovery model from bulk log, so from the full to bulk logged.
Okay.
Daniel, when you said like 20%, what do you mean by that?
I'm getting there. I'm going to explain that. So when you're changing, so the normal scenario is that if I'm trying to perform the same transaction using a full recovery model and a bulk recovery model is going to write only 20% of the total entry where the full transaction is returned to the transaction log. Let's say the full transaction write 100 lines of information to the transaction log. The same transaction can be done with the 20 lines inserted in the transaction log through the bulk log recovery model. Now, what that 80% less information returned to the transaction log is going to come with a price tag. The price tag is that 20% is going to support only a rollback statement. It is not going to support an undo redo operation. So whatever information returned into the transaction log for the bulk recovery model is only going to support a rollback statement. Let's say I inserted 1 million records before I commit the transaction, I decide to roll back. Well, that is being supported. But if I insert 1 million records, transaction is being committed, but before SQL Engine write those dirty pages, before SQL Engine get a chance to write those dirty pages back into the hard disk, the server got rebooted, and then when the server comes back online, whatever information returned to the transaction log as part of the bulk log recovery model is not going to support that undo redo operation. So those 1 million records are gone. Okay. So bulk log recovery model. Just a second. So the bulk log recovery model will help you to write lengthy transactions with the quickest possible time, but the price you are going to pay is it is not going to support undo redo operation. Yes, what's your question?
I wanted you to come back and say what you said, that statement you made again.
I'm sorry, what is the question? I couldn't able to hear you properly.
No, I wanted you to explain again what you just said.
The 20% less information returned to that. So when you are trying, when a transaction happens and the transaction is going to return 20% information, that means the transaction log recovery model is going to be bulk log. The recovery model of the database is bulk log. Then SQL Engine is going to write only 20% information to the transaction log comparing to a full recovery model. So that 20% information is only going to support the rollback statement. It is not going to support the undo redo operation or the data recovery, database recovery. We talked about database recovery before, right? So the bulk log recovery model is not going to support undo redo operation or database recovery. It is only going to support a rollback statement.
Yeah, I got that. So Daniel, it means whenever we have a database into bulk recovery model, so if the power goes off or anything happen, so whatever the transaction that are in the memory, I mean, whatever the data changes that are in memory and were supposed to be written down into the MDF file.
No, it is going to be gone. Those data changes still there in memory, not being returned to the hard disk, is going to be gone.
So it's all gone, right?
Yeah, okay. That's the problem. That's the price you are going to pay for going for the bulk logged. But the advantage you are going to get is faster transaction, right? Faster load, faster insert, update, and delete. That's the advantage you are going to get. So it's a trade-off between what you want.
Daniel?
Yes.
If we are trying to update 100 transactions, out of which only 20% will be there will be available with us, right? What 20%?
No. Are you saying that you have 100 transactions, only 20% is no? I'm only talking about information of the transaction returned to the transaction log, right? If you have 100 transactions, all the data changes happen in that 100 transaction is going to be there.
Mm-hmm.
But information about that 100 transaction returned into the hard disk is going to be 80% less or only 20%. That let's say you purchased a vehicle and then for a year you use that. Let's say for a year you use that vehicle for, let's say, 20,000 miles. Okay, so you drove that vehicle for 20,000 miles, but you forgot to write all the information your vehicle mileage log, so you return only like here and there information. So at the end of the year you drove 20,000 miles, but the information you logged into into your vehicle mileage log is going to be way less because you are you are careless or you are lazy to write all those.
Okay. So what is there any particular criteria that which all information will be the 20% and which will be left out?
Yes, SQL engine is only going to write information which is necessary to perform a rollback. That is what going to be written in the transaction log if the recovery model is bulk logged. Whatever information needed to perform just a rollback, that is the bare minimum information SQL engine is going to write into the transaction log.
Okay.
Clear now?
Yeah.
Okay.
Daniel, this question.
Yes.
So you said that most of the inserts, those kind of transaction million row, heavy workload usually done at off peak, not on the peak hours, right? When everybody is especially happens at night or things like that. So if you know that there is a lot of big transaction coming at night when there's a lot less user, that's the time you can use this kind of functionality to temporary, because there is not too many updates happening from other users. It's just a one big batch of million row.
Yes.
And then you put back, right? That would be the best case scenario.
Yes. And if you are expecting a heavy load or a huge volume of data coming on a nightly basis, and then let's say you try to load it with a full recovery model and then it's taking too much time, so you want to increase the performance of that, then you will decide that, okay, every time when that load happens, before that actual load happens, you change the recovery model to bulk log and then insert or update or delete that large volume of record. And then once that is done, you will put the database back into full recovery model, and then but still you still have that issue, right? In case something goes wrong, the information is not there. So what you will do, you need to immediately issue a checkpoint command, or you create a full backup of the database. So that.
Gotcha.
Yes.
Yeah. So before you run this heavy process, you get everything, whatever you have in existing transaction log, you try to get all the information, make it pretty much fresh, and then you run this process.
Yes, that's right.
Because in a working hour, it's definitely not worth it to make this kind of changes.
Not only worth it to, and then you don't want to put your production database on a bulk logged.
Absolutely, yeah.
It's dangerous. So we normally do a switch from full to bulk log only when you really need it for a large load, and then you immediately put it back to full and then issue a checkpoint.
There is no way to do the analysis saying that, okay, if it's coming this many transaction, if I don't change it, this is the time I usually get historical, but by changing to bulk log, X amount of time I can be saving. Is there any kind of
yes, there are
analysis?
Yes. There is a performance tool. There's a SQL Server, load tester. It's a built-in tool available in SQL Server. SQL Engine can analyze the transaction log entries, and it can tell you how much time we are going to save by switching to a bulk log recovery model. Yes, you can do that.
Yeah, that would be the best. Then you know that how much gain, how much time saving you're gonna get to do all this thing.
Yes, I mean nowadays not a big deal. But normally we will keep the transaction log files on a flash drive, which is going to get the best performance out of it. But still, if you see performance, if you still need performance boost, then one of the option you go for is recovery model to bulk logged. Okay, so a common misunderstanding is that if you go for a bulk log recovery model, nothing is going to be returned into the transaction log. That is not true. Information still needed in case if you want a rollback, right? If the rollback is not supported, it is not a transaction. So low volume of information will be still returned into the transaction log. Is that clear? What is the difference between a full and bulk logged?
Hello, Daniel.
Yes.
Yeah, you said before the 20% of the total entry will be returned back. I mean, is that will select based on certain pre-criteria, or just there is any pre-existing condition in which the SQL engine selects certain amount of data, or just it is general thing?
It is general. I mean, SQL engine will decide how much data for needed for perform a rollback. That information is what returned into the transaction log. It's up to the SQL engine to decide what information. Well, the only thing is that that information is going to be enough to perform a rollback statement.
Okay, so it will not do any selects, just selection, something like that.
No, it's not going to do that.
Daniel, when we change this recovery model, isn't it that we have to do the backups?
Well, you don't need to do the backup when you change it, but if you switch to bulk log recovery model, after that the lot of let's say you perform 1 or 2 transactions, and then you want to cover that transaction against data loss, then you need to perform a checkpoint command, or you can create a full backup of the database. If you want to make sure that in case there is a data loss, you can use that backup to cover that data loss.
So is it, can I ask something? So is it safe to say that you're not going to lose anything? Let's say if there is a production data right now, and let's say you're making these changes from, if it's not so sensitive databases and you're trying to do something, let's say emergency. So you change from full to bulk, you let the transaction go, and then you put it back to full, and let's say something happened in between, you are still safe enough to recover everything while you made those changes all.
No,
right?
Because you changed that to bulk log, you had a couple of transactions to go, and once the transaction is committed, you change that to full. But whatever data changes happen between that 2 full recovery modes, which is the bulk log, right? Those data is still going to be there in memory, assuming that's still going to be there in memory, and then suddenly when the power goes off, that data is lost.
So it's either way you look at it, it's kind of not, a little bit risky. Gotcha.
It is risky, so you always need to issue a checkpoint. Once you issue the checkpoint, data is going to be flushed into the hard disk, then you are safe. Or you create a full backup, you are safe.
We issue a checkpoint only when, right now I'm in a bulk recovery model, and then I go back to full recovery model. Then I issue a checkpoint so that everything.
Yes. Initially you are in a full recovery model. You change that to bulk logged, and then from that point onwards, your risk level goes up, right? The moment you change that to bulk log, your risk level goes up. Then whatever data changes happens, it happens, and then you change that to full recovery model. So in between, whatever happens between those 2 full recovery models, well, it is still in risk. So you need to issue a checkpoint so that that checkpoint is going to flash all the data changes happen in between those 2 full recovery models back into the hard disk. So then after that, you are going to be safe.
Okay, I got it. Thank you.
All right. Elchap, you have been unmuted. I saw your message late. Sorry. All right. How about the simple recovery model? Simple recovery model, you're never ever going to put a database in a simple recovery model, because in a regular scenario, when a transaction gets committed, still information about that transaction is going to be there in the active section of the transaction log. We talked about the active area, active entries and passive entries in the transaction log. So even after committing the transaction log, information about that transaction is still going to be there in the active portion of the transaction log, because that we need SQL engine need that to perform an undo redo operation. But if you are going for a simple recovery model, information about the transaction log is going to be all information about the transaction log is going to be returned into the transaction log. But the moment the transaction is completed, SQL engine is going to wipe out those entries from the transaction log. What is the caveat of that? Just after the transaction is completed, when if SQL engine delete all those entries about that transaction from the transaction log, what is the price you are going to pay for that?
Is it just like you can do the rollback at the same time, but if the lights go off, power goes off, anything happens, then you cannot do anything?
Yeah, it is not going to support. So those entries are not going to be there when you need a undo redo operation, right? So it's very, very dangerous. So we never ever go for a simple recovery model. Simple recovery model, at any point, whatever information available in the transaction log for a simple recovery model are currently active transaction. Currently active transaction means a transaction which has been started but not yet committed. Those are called as active transactions, right? So in a simple recovery model database, the transaction log only going to contain active entry transaction information. It is not going to contain any information about transaction which is already been committed. So you never ever see a transaction in a simple recovery model. Oh, sorry, you're never ever going to see a database in a simple recovery model. Very dangerous. But if your database is in it, now the question is why, if it is too dangerous, then why SQL Engine Microsoft provided that option? Well, simple recovery model is a good choice if your database is primarily a read-only database. Read-only database, when you're going for a simple recovery model, then SQL Engine is going to put less locking, so your read operation is going to be much, much faster. Your transactions are going to be much, much faster because it's a simple recovery model. So you are going to get the best performance for your transaction in a simple recovery model, but there is a possibility of data loss.
So is it safe to say that for data warehousing and things like that,
data warehousing, reporting, or if you have a database where you don't care about the integrity, you can afford to lose that, you can afford data loss, in all those scenarios, you can go for a simple recovery model.
So when the database is read-only mode, will there not be loss of data as well when it's on simple mode?
Yes, I mean the database is primarily a read-only database, then we are not expecting any data loss, so you can easily put that into a simple recovery model.
Okay.
So technically, you really don't need the other options if it's for reporting purpose, right? That's a good check to do.
Yes.
Because you can save a lot of performance issue.
Yes, by flipping it to simple recovery model. Yes.
Yes, because I bet you a lot of people probably have a habit of keeping it safe, and even if it's for reporting, they might be on a full.
No point in keeping that and a full recovery model. Yes, because you're not expecting any transactions there.
True.
Daniel,
yes.
One question.
Yes, Tejal.
So suppose it is full, right? So and the transaction is complete and the data is already written on the hard disk and everything. So what will happen to that active transaction? It will anyways go away, right? From the transaction log.
From the active, and the moment the transaction is committed, and then later information, those dirty pages returned back into the hard disk, those entries are not active entries in the transaction log. It is going to be converted as passive entries in the transaction log.
Okay.
And then the moment that particular virtual log contains, 100% of that virtual log entries become passive entries. Those passive entries is going to be deleted by the SQL engine.
So Daniel, then the other question is, with this full recovery, so how will it recover? See, if the passive entries are deleted, right? So if there is a necessity for a full recovery, do you think it will still recover? It will only recover the active ones, right?
No, because let's say I committed a transaction. Okay, I updated 3 records in a database in a table, and then I committed the transaction. But still, and then those data changes are still there as a dirty page in memory, but information about transaction is going to be written physically into the transaction log. And even if my transaction is committed, data changes are still there in memory. The entry about that transaction is still going to be there in the active section of the transaction log, right?
Right.
Okay, now let's say SQL Engine issued a checkpoint. So my dirty pages is now flushed to the hard disk. Okay, so now the moment my dirty pages return back into the hard disk data file, SQL Engine will also move my active entries in the transaction log to the passive entry section of the transaction log, because SQL Engine doesn't need that entry for a undo redo operation, because that information is already physically written into the data file, right?
Right.
Are you getting my point?
Right. So basically, with the full recovery, since it's already written in the MDF file,
Yes.
it can be recovered.
Yes.
Anyways.
Yes.
Okay. Makes sense. Okay. Thank you so much.
Sorry, last question.
Yes.
Last question, Daniel. When you mentioned about, let's say there is a situation where the huge transaction doesn't come every time, but if it's a year end and you forgot to plan ahead, and if someone posts this really huge batch, now if it's so many hundred thousands of row and you already know the process already started, how about the transaction log? Because you didn't plan that much, before. You only kept so much space for the transaction log, but the thing is happening right now. So what can you do? Let's say if you are in a situation where the posting is already started and everybody's complaining about the database is hanging.
Well, you cannot do much. I mean, you need to make that choice. You want to kill that transaction and then wipe out the data, or let it continue what it is doing. Normally, when you perform a load like that, you are not going to directly load that into the actual tables. You load that into more like a staging table. So the advantage you are going to get is that if you see a lot of performance, you can cancel the transaction without worrying about data inconsistency, because you are not directly loading that into the destination table. You are loading it into more like a staging table. Okay, so if you accidentally load data, or you loaded data, you started loading data without much preparation, at any point you can cancel it and then restart it whenever the prepared work is complete, appropriately done.
Right. So let's say the transaction already went to the staging area. Now, in order to bring it to the regular table, when it happens, it's going to consume the same resources, because I agree with you that it should go to the staging first. But let's say staging part is already done. Let's say the process started at 5 a.m. and it's 8 o'clock. Staging part is done. Now it's coming from staging to the production. Is it going to take the same amount of resources? I mean, I know.
Yeah, because I'm not saying that it's going to be this, because normally we load this kind of data into a staging and then we process that. We will transform. We will call it as extract, transform, and load. So we will process and then we massage data that we will convert that into a format which can be put into the actual table. All right. So if that process is already started, I mean, you cannot do much on that.
But you're right.
If you cancel that, then the question is that how you are going to clear out all the records already been inserted into that table. So there are a lot of other logical questions before you cancel that.
So the good practice is to load them into a batches. So like from staging to the regular tables, if it's going, ETL should have some kind of limitation, right? If it's this many transactions, you take a break, that way you can manage it better.
Yeah. So what we normally is that you can either go for bulk log. I mean, if you cannot afford bulk log, if you really care about data loss, then you can you can break it into multiple smaller transactions. Then in that case, you can go for full recovery model. Instead of going for a bulk log, you can break it into multiple smaller. Then you need to the logic is going to be a little bit complicated if you want to break it to multiple smaller transactions.
Yep. Okay.
Hey, Daniel, I have a question.
Yes.
When we issue a kill statement for a transaction or a SPID, is it going to roll back the transaction if it's in the middle of the transaction, or is it?
you can the SPID, you can use the kill statement to kill the kill statement is for killing a particular connection. So if you're killing a connection, then all the transactions in that particular connection is also going to be aborted, and the transaction is going to be rolling back.
So it's a rollback, right? Like if I'm unloading like 10,000 records,
Yes.
and I already loaded like 5,000, I'm like killing that transaction. So all those will be gone also, right?
Yes, yes.
Okay.
You can do that.
Hello, Daniel.
Yes.
So during recovery, is that the file location will be affected? Let's say certain file is in location A, and and during the processing or transaction, something is happened, and just is on recovery mode now. So is that during the recovery, that file location will be affected,
No,
or it will
no,
be
the
coming
file
back to the
location
original
has
location?
nothing to do with the recovery. File location has nothing to do with a database recovery model or the database recovery process. SQL Engine already know what the files are, so it's not a problem.
Okay.
So Daniel, sorry, one more.
Sure.
So full recovery means, let's say if there is 100 people doing 100 insert, update, all those modification
Under
in the full. Yes, modification. So basically, the SQL engine is smart enough to assign each and every single millisecond when the thing happened to a LSN number, line sequence number, and then from there, when something goes down, you can bring everything because you have that sequence number. Is that right?
Yes, I'm going to show you the sequence number. It's going to explain more. Even if I said it is going to be a sequence number for each and every entry. Now, how about 100 users is having 100 transactions running simultaneously? If it is going to be a sequence number, there is going to be a mix match, right? The entry number 1, let's say 001 belongs to transaction number 1, then 002 belongs to transaction number 2, then 003 belongs to transaction number 1 again. So, but it's not a 100% sequence number. Let me show you that, okay? In 5 minutes,
Okay.
you are going to see how information is going to be returned into the transaction log. So the next thing is, let me cover the transaction log maintenance, and then we will see how to query data from a transaction log. All right. So now let's talk about how to maintain the transaction log. Transaction log maintenance is based on to maintain transaction log.
Sorry, Daniel, did you explain line 6 and 7?
Yes, I did. Every time when the SQL Server is stopped, SQL Engine is going to perform, you're talking about this bullet point 6 and 7 or line numbers 6 and 7?
No, the bullet point 6 and 7.
Yeah, every time when the SQL Server is stopped, it is going to perform a checkpoint. And every time when when the SQL Server failover clustering is going to fail over, it is going to perform a internal checkpoint. Okay. Maintain transaction log. So there are two actions. One is truncate transaction log. Second one is shrink transaction log. So we all know that SQL Engine periodically, if SQL Engine identify a virtual log is completely full with passive entries, it is going to clear out all that entries in that virtual log, and then that virtual log space is going to be reused at later point. That process is what we call as truncate, and SQL Engine efficiently do that. But if you see that, but the SQL Engine is now the only way SQL Engine can move more active entries from the transaction log to the passive entries by performing checkpoints. But if the SQL Engine is too busy issuing the checkpoint, that means more and more active entries, the active entry portion of the transaction is going to start growing because SQL Engine is not issuing checkpoints frequently. So, and then on the other hand, if due to XY reason SQL Engine is not optimally clearing out the virtual logs, then also you will see that the transaction log is start growing. All right. So now if you want to reduce the size of the transaction log, that's what we called as maintaining the transaction log. So if you see that your transaction log file size is growing exponentially in terms of, for 300 GB, 400 GB, now you want to check and see whether how many free space and then release that space back to the operating system. So you need to perform two tasks. First one is you need to manually truncate the transaction log. Instead of depending on the SQL engine, you can go and manually truncate the transaction log. Now, from SQL Server 2008 onwards, prior to 2008, there was a DBCC statement for this, which has been discontinued. So the only way you can truncate a transaction log manually now is you can change the recovery model from full to simple. It's a dangerous thing to do, but we are not going to keep that recovery model to simple for a longer period of time. You will immediately pull back to full. So this is what we are going to do. Okay. So you need to change that to simple. Let me show you the script for that. So you say alter database name, set recovery simple with innovate. With innovate is not needed. Simple statement is that alter database name, set recovery simple. So when SQL engine execute this statement, what happens behind the scene? Based on the explanation I made 5 minutes ago about the simple recovery model, the moment you put the database from full recovery model to simple recovery model, what happens? What information is there in the transaction log? Yeah.
Active entries.
Yes, it is because in a simple recovery model, SQL engine is only going to keep the active transactions entries in the transaction log. So when this database is in a full recovery model, there's going to be a lot of entries in the transaction log, which is active entries and passive entries, right? The moment the SQL engine the moment you put the database into a simple recovery model, all the other entries are going to be wiped out immediately. So all
you
the
mean the passive or the active?
All the passive entry, not all of them, passive entries is going to be completely wiped out from the transaction log, which is nothing but the truncate, right? When you are wiping out.
But not the active. It won't wipe the active, is it?
It is not going to wipe the active, no. It is only going to wipe out the passive entries. All right, so which is nothing but the truncate, right? Wiping out the passive entries is what we called as truncate, right? Now, the only advantage is that it is not looking for a virtual log level. If a virtual log consists of 50% passive entries, those 50% will also be gone. When SQL engine perform internal truncate, it is going to perform at the virtual log level. But when you are switching the SQL engine from full recovery model to simple, even if a virtual log consists of 50% passive entries, those entries will also be wiped out. Okay. So once that is done, but still your let's say your transaction log file size is 450 GB. By performing a truncate, do you think that's going to reduce the size of the transaction log? Performing a truncate, do you think the truncate will reduce the size of the transaction log from 450 GB to probably 100 GB or 50 GB? What do you think?
No, it will just
virtual log will stay.
It is not going to release that vacant space. It's going to keep it so that it can reuse it. But if you really want to reduce the size of the transaction log, first you need to perform a truncate so that you are going to create enough free space in the transaction log. After that, you need to perform the second task, which is called as string transaction log. Now, if I
Mr. Daniel.
Yes.
Sorry, I have a quick question.
Yes.
Under the truncate transaction log, why did it set the recovery to the simple?
Because that's the only way you can wipe out all the passive entries from the transaction log. You need to put that into a simple recovery model, and as the basic behavior of the simple recovery model is, it is going to keep only active entries, passive entries going to be immediately wiped out. So this is an indirect way to remove inactive entries or passive entries from the transaction log.
Okay, Daniel, why is the, like, I know you said it before, but I am confused. Like, why isn't the database doing it by itself, the system doing it by itself?
Why we are not letting system do it by itself?
Yeah, why is it growing? You said it before also, but I'm
Because SQL Engine is not going to perform enough checkpoints. So when your SQL Engine is not performing enough checkpoints, or SQL Engine is not clearing out, SQL Engine is too busy, writing information to the transaction log. It is not maintaining its passive entries properly. So see, you will come across situations where SQL Engine, if the SQL Engine is more, lot of transaction happening, the first priority for the SQL Engine is to write those information about the transaction into the transaction log file than clearing out passive entries. Okay, so if that's one of the reasons, if there are a lot of transaction happening in the database, and then if there are a lot of transaction happening in the database with lengthy transaction happening in the database, that's also a time where you see the transaction log is going to grow exponentially. Now, to clear that out, you can perform a truncate transaction log. So if the SQL Engine is not keeping up with its job of clearing the passive entries, then you need to truncate the transaction log by yourself by changing the recovery model to simple. And you don't want to keep your database in a simple recovery model for a long period of time. So we normally execute these two statements, line number 16 and 17, next to each other, so that it's going to simply put that into, you are going to put the recovery model into simple, and then the next statement itself, you are going to put it back to full recovery model.
So how many seconds does it take to put it in recovery mode, truncate the transaction before bringing it back to
That's a very
full?
good question. The moment the amount of time SQL Engine need to wipe out all the passive entries might take, let's say, 5 minutes or 10 minutes. But the thing is that the moment you put the database in a simple recovery model, SQL Engine will already issue a command to clear that transaction log. It will provide a command to the transaction log to clear out all the passive entries. That process might take 15 minutes, 20 minutes, maybe an hour. Doesn't matter. It's already in that process. So then once that process is started, you can immediately put the database into a full recovery model. So there's no time gap needed between line number 16 and 17. The 16 itself will start that process. So once the process is started, you can issue the line number 17 and put it back to full. You don't need to wait for that process to be completed.
Daniel's question.
That means you will execute as one body part, both of them, 16 and 17?
Yes, you can execute as one single batch. Yes, like this.
Okay.
Okay, Daniel, let's say if you have a planned maintenance at 6 p.m. and you are, users has been notified that, the system will go down. So that time at 6 o'clock, you know that everything, whatever the entries came in, you need to recover those and put it into a backup somewhere. So how do you make sure that every single thing that was in transaction log that you were able to capture a full complete backup? Is there like is there ever the data gets corrupted in between that you would never know?
When you are creating a backup, SQL Engine will internally issue a checkpoint, right? So when you are creating a backup, whatever data which is already there in the data file, those dirty pages also going to be returned into the hard disk before you perform a backup. Because if you look at the internal checkpoints, the line number, the bullet point 3 says a backup is taken. Every time when you start a backup, it is going to issue a checkpoint. All those dirty pages will be returned into the hard disk, so that your backup is going to contain all those data changes. So you are not going to have a corrupt data or inconsistent data as a result of backup. Is that what you asked me?
Yeah, so that's at 6 o'clock, you start taking a backup. So every activity came in till 5:59. As soon as you start that process of backing, the full backup from last night and all the activities till 5:59 p.m. you will have in transaction log. Mm-hmm. So they will all get recover.
Yes.
Yes. Goes into a backup.
Then it goes into the backup. Yes. That's right.
Yep. Thank you.
All right, let me finish this topic too. So Truncate Transaction Log is going to clear out all the passive entries. Now, how to recover those unused space from the transaction log? If you want to recover unused space from the transaction log, you need to perform a task called as string. So in order to perform the string, you can use the point and click method. You right click on any database, go to the task, and then there's an option called as string, and go to the files. Now you go to the file type is log. Okay, log file. Now SQL engine will tell you how much space you are going to, how much free space available on that transaction log file. If you see that there is no much free space, you don't need to perform a string. But in our case, the total size of the transaction log is 176.94 megabytes. Out of that, 10.91 megabyte is free. So you need to also choose release the unused space back to the operating system. Okay. Now, if you click OK, it's going to string it, but I want to show you what is the corresponding script for this. So I'm going to copy this, paste it here. Now, to your surprise, you will see that this is a database consistency checker or DBCC statement. And so the DBCC string file is going to string the transaction log file. That is going to have three parameters. The first parameter is what is going to be the name of the file, which is going to be adventurework_log, which is my transaction log file for AdventureWork database. Now the second parameter is what is your expectation after the string, how much space you want. I mean, I'm saying that, okay, after the string, I want 0 megabyte. That's not going to happen, right? So SQL engine will try its best to give you whatever your expected numbers are, but let's say it can only string to, let's say 5 MB, it is going to do only up to that. The second parameter is your expectation, but SQL engine will try. But only thing you need to be careful is that if let's say you have a 450 GB transaction log file, okay? Now that 450 GB transaction log file contains 90% free space and 10% actual data. So that means it contains 45 GB of actual data and rest of the space are blank space. Are you going to shrink that transaction log directly into a 45 GB? Never ever do that. Because if you are trying to string a extremely large transaction log into a very small size, most likely SQL engine is going to put a lock at the database level so that no transaction, nobody can connect to that database. I came across these kind of scenarios a lot. So my advice is always do step by step. Let's say you want to reduce that 450 GB transaction log file size to, let's say 45. You go from 450 to 400 first, then 400 to 350. You need to do that by step. Never ever reduce a huge transaction log file from that huge size way down to a very small size. Never big. The problem is that SQL engine tend to put a database level lock so that entire object in the database is going to be locked for this particular process. So all the transactions currently executing need to wait. Okay. So this is what that string. So when we talk about main transaction log maintenance, it's two tasks. One is a truncate and one is a string. Now, my question for you is, how frequent you string the transaction log, or is it necessary to string the transaction log? We normally don't string the transaction log because we only truncate it. Because if I string the transaction log to bare minimum, in the next 1 second, it will try to start recovering that space, right? Because the more and more transaction is continuously happening. So even if I string to the bare minimum, it start recovering, it start requesting operating system to have more space. So to avoid that, we will keep, unless and until you have some space constraint in that particular disk, you wouldn't worry too much about the size of the transaction log. The only thing you will make sure that transaction log is, always be truncated so that there is enough free space. Okay, so shrinking the transaction log is a rare thing to happen. But if you want to reduce, if you have a space constraint, storage constraint, and then if you want to reduce it, you can definitely do that by performing a truncate and string.
Hello, Daniel.
Yes.
Yeah, let's say I did shrink transaction log and the space is little bit, it is just shrink it to small. And after how long the SQL engine starts appealing to have more space?
If whenever the SQL engine, whenever the transaction log is full, if you have 450 GB, you reduce that to 5 GB, and then that 5 GB is full, it will ask for more space, right? Every time when the database transaction log is full, that's when the SQL engine will appeal for more space.
That means it will start appealing right away after shrinking.
Yes. I mean, if I'm shrinking to 10 GB instead of 4, then you are going to give SQL engine some room, right? Right now it is for 4 GB data. Now you are shrinking to 10 GB. Now there's additional 6 GB free space there, and then SQL engine will use that 6 GB first. Once that 6 GB is consumed, SQL engine will ask for more space.
Okay, thank you.
Okay,
Daniel, isn't that truncate happen automatically in normal circumstances?
Normal scenario, it is going to happen automatically, yes. But if you think that the SQL engine is not doing its job properly, then you can go and manually truncate it.
But whenever a truncate happens, does the shrink also happen automatically or no?
I'm sorry, did you ask for the shrink? I thought that you were talking about...
I asked for the truncate first. Now I'm asking the shrink.
Okay, shrink is not going to happen automatically. You need to manually do that.
Okay.
Shrink will never happen automatically. It's something you need to do manually.
So Daniel, rather than shrinking, you can also force all the transaction to get into a disk, right? That way you can make the transaction log free.
No, you cannot do that. You cannot redirect all the entries into a disk. You cannot redirect the entries to a particular disk file. You cannot do that. SQL engine will automatically write to whichever the predefined transaction log. That's where the transaction log entries are written.
Gotcha. Okay.
So
Daniel, when we shrink a file or shrink a database, does it affect the fragmentation level?
When you are shrinking the database, well, you can shrink the database. When you are shrinking the database, you are shrinking the data file and the log file. We normally don't get any additional benefit from shrinking the data file because the maximum you might get is that there might be some 8 kilobyte page doesn't contain any data that is going to be removed, but you are not going to get any big benefit shrinking a data file. You can certainly shrink a data file, but you are not going to get benefit out of it. So it is not going to affect the fragmentation now.
Okay, thank you.
Sure. All right, give me 5 minutes. Let me show you how to query data directly from the transaction log. And now we
normally don't do this, right?
Normally do what? Like shrinking the data file?
You're shrinking the data file or the log file.
We normally don't string the data file for sure. If you want to reduce the size of the transaction log due to XYZ reason, you string the transaction log file size. Okay, but we are never ever going to string the data file.
Okay, thank you.
And so we shrink the log files just to create some more space.
Shrinking is going to reduce the size of the transaction log file.
But it doesn't create any space.
It's not going to create any space. It is going to reduce the size of the transaction log file.
So what's the benefit of reducing the size?
If you think that, let's say there's only like a 500 GB in that particular drive, and 450 GB is already used by the transaction log. So there is a possibility that that disk will run out of free space, right?
Mm-hmm.
So that time, if you want to reduce the size and then reduce the size of the transaction log, then you perform a truncate, and then followed by you perform a shrink.
Then will it provide additional space for you for more log files? Since we have 450 the space occupied? And if you shrink, does it reduce to any like 300 or so?
You can reduce that. Depends on how much free space you have in that transaction log. It can be this, let's say, so that's what I said. I mean, in the transaction after the truncate, the transaction log contains 45 GB, 10% actual data, and 90% free space. You can reduce the transaction log size to just 45 GB. The size of the transaction log will come down from 450 GB to 45 GB then after the shrink.
Then more logs can go into that file again. Is that?
Yeah. More entries can go into that transaction log file. Yes.
Daniel.
Yes.
One small question along with that. If I'm not shrinking a data file, like you said, if we say the log file for 100 GB and 50 GB is the real data and 50 GB is not the real data. I mean, already been truncated but not shrink. So will it use that space also, like 50 GB, whatever is still available? I mean, it's been truncated, not being shrinked. I mean, there's no shrink operation done on that. Will it still reuse that truncate space, right?
Yes. That's why SQL Engine do the truncate, because that space can be reused.
Okay. I got it.
Always do that.
So restarting services, when does that play a role? Let's say if someone is running a huge report, that report has a lot of updates and some data changes happening while the report is running, and if people are complaining they're getting an error. Is that restarting service sometimes helps, or that's totally different?
No. I mean, if you're getting an error, restarting the SQL Server is not going to fix anything. There might be some issues which you need to identify with that report, and then to solve it, then restarting the SQL Server is not going to do any good. That's not.
Services, yeah.
No, it's not going to help you anything.
Okay.
All right. So I'm going to create it. Now let's talk quickly, see how you can read information from the transaction log. This topic is going to really help us when we talk about how to perform transaction log backups. So I'm going to create a very simple database called as a read DB log. The simplest database create statement is going to be create database followed by the database name. SQL Engine automatically create the data file and log files in default locations, etc. So let's go and create it. All right, database is created. If you right click and refresh it, you can see reading the DB log is created. Now I'm going to perform some transactions here. First, I'm going to create a table called as location table. Just a regular table, nothing fancy. All right, table is created. Now, if I want to read entries from a transaction log, I mean, you cannot right click and go get any information from the transaction. If you want to read information from the transaction log, you need to use a function called as fn_db log followed by 2 parameters. And then this is going to show you a lot of information. Let me execute that statement and then we will discuss that. So right now, entries in the transaction log for reading DB log database is this much. There's no record inserted. Well, you can see that this is a transaction corresponding to that create table statement. Now, any transaction in SQL Server, any transaction, when a new transaction starts, the operation name is going to be loop_begin_exit. So if you see an entry in the transaction log with a loop_begin_exit, that is going to be a transaction. And then you can see the transaction name says that, okay, what you're trying to create. So it's going to be a create table statement. And this is a transaction ID. Each transaction has its own unique ID. And then who is created this? It's created from connection ID 54, right? You can see the connection ID 54 when the transaction is started. And where is the log sequence number? This is the log sequence number. I mentioned that it is more like a sequence, but it is kind of a sequence because when this create table statement, how many entries are there in the transaction log for that create table statement? Can anybody tell me? How many entries are there in the transaction log for that create table statement?
4.
4 of them. How do you say 4?
It started at 001 and it goes till
Right.
04.
So the transaction started with a loop begin exat and the transaction ended with a loop commit exat. So you can see that these 4 entries are corresponding to that create table statement. Now, if you look at the log sequence number, well, the actual log sequence number is ending with 070, and then there is a sub number 0001, 0002, 3, and 4. You can see more like it. So any transaction, there is going to be a constant part for the LSN and a sequence part. The constant part in this transaction is going to be, too many zeros, 22 colon, another set of zeros, 70 colon. Those are going to be the fixed part of the log sequence number, and the last 4 digits is constantly is more like a sequence number.
So why does it have 4 transactions? Is it because there were 4 lines of code, dates, city?
No, it is always not. Don't think that it is going to be for each statement. It is going to be single line. It is the first one is going to be start of the transaction. The second one is actually created the table. The third one is going to be create a record. I mean, it's going to create a 8 kilobyte page for that, and then the fourth entry is going to be committing the transaction.
So is it same for every create table? Does it have to? Will it be 4 transactions for every table you're creating, or any other create
table
operation?
you create, it is going to be 4 entries.
What about another create operation? Create a function or create a trigger or any other create?
It can be vary. It can be vary from one object to another. I haven't looked into how many entries are there when you create a trigger or a function. I haven't looked into that. But it is definitely going to be more than that. Minimum 2, because, well, there should be 1 entry for start of the transaction, 1 entry for beginning of the transaction. So definitely there is going to be 2 entries for sure.
Okay.
Okay. Now let's go and insert 100 records into this table. Right now, let's say how many entries are here. We have 173 entries. Okay, before we insert a record. Okay. Now the next step is we are going to insert 100.
Sorry, Daniel. What are those other entries then?
Well,
we have so many other entries there, but we are talking about 4.
Yeah, I mean, we are not.
What are the other ones?
Well, SQL engine, I do not know what these entries are. It is most likely it's all going to be internal entries, because the only object we created is the table, right? Well, don't think that your SQL transaction log only contains our own entries. It's going to SQL engine to constantly add its own entries into the transaction log, which we are not really concerned about.
Okay. Yes.
Now we are going to insert 100 records into this table. Let's do that. All right, insert into location default values, and I want to execute that 100 times. So I say go 100. Let's see what it is going to do. Okay. Right now we have 173 entries. All right, if I execute this, all right, all those entries are added. All right, so let's go back and read that transaction log entries again. Now you can see that 170 is some right, 173 or something before. Now you can see that the number of record is increased to 502 records. And now scroll all the way down. Now you can see that for each insert statement, it is going to be separate transaction or the same transaction. It's going to be separate transaction, right? The last record inserted, this is the transaction. It started the transaction, inserted the record, and commit that to the transaction. So when I executed this statement, insert statement 100 times, 100 times that insert statement is executed, and each time it is going to be an explicit transaction. So you can see that start the transaction, insert the record, and commit the transaction. Now, if I go and you can get more information out of it, I'm going to comment this and I'm going to put a star because there are more columns from fn_db log. So if I execute this, now you can see there are so many columns. All right. Some of these columns are useless. Some of them is useful. Now, the reason why I want to show you all these columns because scroll all the way down. Let's pick one insert statement. Let's pick our last one. All right, contest. LCX_heap means you are trying to insert this record into a heap table. Okay. Now the transaction ID is here. This is a transaction ID. And what is the record length? And then if you scroll to your right, did you see this number? 0001:00000140. Can anyone tell me what that numbers are? Give me 1 more minute, guys. So 1:, so you can say it as 1:140. 1 indicates, so each, tomorrow we are going to see this especially when you talk about backup and restore. When a database is created with a multiple data file and log file, each data file is having a unique file ID. So in this particular database, there's going to be only one file, so there is going to be one file ID 1, and then 140 is the page number. So each file is having its own file ID and each page is having its own page ID. So where this particular record is being created, this particular record is created in file ID 1, which is the first MDF file, and the page number is going to be 140. So the transaction log even pinpointly say to which data page or which particular file that record is being inserted.
So you are saying page ID has both file ID and page ID?
Yes, it is the file is always a unique way of identifying a 8 kilobyte data page is file ID : page ID. And that is what you are seeing. Eliminate all those zeros. It is going to be 1:140. 1 means the first data file, and the data page is going to be 140.
Okay.
It's just for information. It is not going to make any change here. Okay. So there are so many different, then you can see when the transaction is started, what is the exact type, whether the transaction is committable or not. We talked about exact about, right? Exact state, etc. That one is, I normally don't go for all these values. Only thing I care about is the log sequence number, what is the transaction ID, when it is being started. Those are the things we normally look for. All right, so this is so you need to use a fn_db log function to retrieve data from a transaction log. All right, sorry to take additional 2 minutes. So that is all for tonight. Tomorrow we are going to start with another interesting topic, backup and restore. So we are going to use whatever topics knowledge we acquired so far, and then we apply that during our backup and restore process. It's going to take a couple of days to complete the backup and restore process. Okay, guys?
Hello, Daniel.
Yes.